So, good afternoon, everyone. I am Dr. Satyabrata, MDDM clinical pharmacologist, and today I am going to discuss on isobologram. Coming to introduction, isobologram is a diagram showing varying substrate and inhibitor concentrations that give constant enzyme activity, and it is introduced by Loy in 1927. And Talarida discussed the use and construction of common linear isobol in 2001. And drug combination analysis can be done by isobologram. So drugs given in combination may produce effects that are more than or less than the effect predicted from their individual potencies. For predicting the effect of a combination is based on the concept of dose equivalence. And for drugs with a constant relative potency, this leads to linear additive isobols, whereas a varying potency ratio produces non-linear additive isobols. And determination of the additive isobol is a necessary procedure for assessing both synergistic and antagonistic interactions of the combination. So there are studies of drug combinations analyzed by use of the isobologram, a graph that was introduced by Louis. And this graph was constructed on a coordinate system composed of the individual drug doses, commonly contains a straight line of additivity which distinguishes additive from synergistic and antagonistic interactions. And this graphical construction is based on a constant relative potency. So this is the isobologram plot that is given in x-axis dose of agent B and y-axis dose of agent A, and there are three curves. One is straight, another two curved, and one is showing synergism, and the middle one is showing envelope additivity, and above that showing antagonism. Now new analysis applicable to two full agonist combinations with a varying relative potency also done by isobologram. The principal aim is to predict the effect of the drug combination and thereby distinguish between exaggerated effects and those that are expected. This analysis requires that both drugs produce effects that increase with dose, and inverted U curves that may occur with higher doses of certain psychostimulant and other drugs must be restricted to lower dose combinations in the isobolar procedure. Then the individual doses that produce the specified effect are determined from the dose effect graphs. These doses are plotted as axial points in a Cartesian coordinate plot termed isobologram, a plot that was popularized by Louis. So this is the graphs given by Talarida, and you can go through the articles or books to know about these graphs more, to learn more about these graphs. So in this plot, each axis represents the dose of one of the drugs and the intercept values represent the doses of the individual agents that produce the specified effect. For drugs A and B, these doses are denoted here in italics AI and VI respectively. The diagonal line connecting intercepts A and B is termed the additive isobol and is commonly expressed in the equation small a by AI plus small b by BI is equal to 1, and 0 less than equal to A less than equal to AI, then 0 less than equal to B small b less than equal to BI. All points A, B on this line segment represent those pairs that give the specified effect. As we will see, the term additive is not based on the addition of effect magnitudes, and thus this invites the question, what is added? The answer to this will emerge as we proceed with the definitions and the underlying assumptions. Then the basis of the linear isobol is rooted in the assumption of a constant potency ratio. It employs concept of dose equivalence, which was described by Louis. Louis concluded that linear isobols of additivity are based on a constant relative potency of the two drugs. Such drug pairs were called homodynamic by Louis and heterodynamic when the potency ratio was variable for such cases. And no mathematical proof or other details to explain this statement given by Louis. In Louis' notation, small b equivalent is equal to DEMB BI is equal to DENB minus A is equal to DEM A minus. Thus, this expression for A plus B is the left hand side. In the left hand side of the equation, he presented in the following way: DEMA plus DENB minus DEMB bracket is equal to DENC. So where DENC denotes the summed dose of the combination, Louis 1953, the graph of figure 1C, when attached to Louis' notations, illustrates how he used the concept of dose equivalence in arriving at the isobol of additivity. In particular, it is seen that the term in the parenthesis above is equivalent to B, the arrow length. In this derivation of the equation of the linear isobol of additivity, we express the dose of drug A as an equivalent of drug B. The same equation is obtained if we express the dose of drug B as an equivalent of drug A, that is A plus A EQ is equal to AI, and because A EQ is equal to BR, we get A plus BR is equal to AI, which is A by AI plus B by BI is equal to 1. So this is quite difficult for understanding, and you can go through different articles to learn more about this. The additive isobol consists of dose pairs A, B. In the absence of drug A, the needed dose of drug B for a specified effect is BI. When drug A is present in dose A, the amount of drug B is reduced to quantity B. If A is equal to AI, then the reduction of drug B is total, that is, no quantity of drug B is needed. This way of viewing additivity will prove useful. Isobols of additivity in cases of constant relative potency lead to parallel lines, one for each effect level. Every additive dose pair AB lies on one and only one such isobol. Then the interest in isobols is mainly to establish a basis for classifying drug interactions. A dose pair A B on the line is expected to produce the specified effect. The actual testing of combinations may reveal an exaggerated effect of the dose combination. Lesser doses A B may achieve the specified effect. When such a combination is plotted on the same axis as the additive isobol, the point will be in the upper quadrant but below the additive line. Conversely, if the combination results in a reduced effect, then greater quantities of drug A and B are needed to get the effect, and the point A B will appear above the additive line. The set of supra additive points gives rise to upward concavity, whereas the sub-additive set shows downward concavity. Coming to examples, an early example is given by Gessner and Cabana, 1970, who described the hypnotic effect of chloral hydrate and alcohol using the writing reflex as the effect measure. Locomotion was the end point in studies in Haldeman's laboratory. Kimmel et al. 1997 that examined combinations of cocaine and buprenorphine. Pasternak's group has been concerned with mu opioids in combination. Bolan et al. 2002 and Field et al. 2002 looked at combinations of gabapentin and NK1 natural killer 1 antagonist in a model of neuropathic pain. Neostigmine was shown to interact synergistically with non-steroidal anti-inflammatory drugs, that is given by Miranda et al. 2002, Talarida 2002. Especially in some cases in which one of the two compounds lacks efficacy but whose presence enhances effect of active compound. An example of that situation was evident in work in Poreka's laboratory that examined opioid delta receptor agonists with morphine. Horan et al. 1992. A more recent study, Talari et al. 2003, demonstrated that glucosamine, which lacks efficacy in the mouse abdominal constriction test, significantly enhanced the anti-nociceptive activity of both ibuprofen and ketoprofen. That was given by Talari et al. 2003 in 2003. Numerous other studies have proceeded to analyze combinations with isobolograms. An especially interesting application. The same drug is given at two different sites. That was by Rafa et al. In 2000, demonstrating site additivity or synergism. Basis for this application is also concept of dose equivalence, that is, potency at one site has its equivalent value at the other site. Synergistic interactions have also been examined for enantiomers of an active compound, which tramadol. That was also by Rafa et al. 1993. This study showed that the plus and minus enantiomers of tramadol each independently produced centrally mediated antinociception in a standard test of antinociception in mice. The racemic compound was found to be more potent than the additive potency predicted from the enantiomers. So this is another graph about the isobologram, that is plotted showing the super additive, sub additive, and also other things that you can learn from different articles and also from the book. You can go through this graph and learn more and more about this isobologram. So this is another diagram showing isobols of additivity for an effect equal to 50% of the maximum for two full agonists that have a variable potency ratio. In this situation, the departure from additivity is demonstrated by values of B that lie outside the interval defined by the vertical segment ST. The diagonal straight line is drawn to enhance the recognition of the symmetry and is in fact the additive isobol that results when exponents P and Q in equations 8 and 9 are equal. So you can go through different articles about isobols, and these pictures you can learn more and more from articles and also from the books. So coming to summary, when the two drugs exhibit a constant potency ratio in the production of the common effect, that combination will produce a linear isobol of additivity that provides a basis for distinguishing super additive and sub-additive interactions. So the additive isobol is based historically and logically on the concept of dose equivalence. When one of the drugs is a partial agonist in the test used, the additive isobol calculated using the dose equivalence with the requirement that sufficiently large dose pairs should produce the maximal effect. This analysis leads to additive isobols that are not straight lines. So these are my references. You can go through these articles, these references to learn more and more about isobologram. Isobologram is a difficult topic in pharmacology, but you can go through different articles and books, and you can learn more and more about isobologram, and you can gain a lots of knowledge about isobologram further. So that's all for today, and please watch my videos and like and share and subscribe my channels, and thank you again for watching and listening to my videos and subscribing my channels. Thank you very much. Stay safe and God bless you. Jai Jagannath.